Example number 2. A channel suction carries two concentrated loads W and a total distributed load of 4W as shown here. So the 4W is already a resultant. Hindi nga naman siya a total distributed load, meaning total distributed, meaning resultant of the distributed. And the location of the neutral axis is 2.17 inches from the bottom of the suction. Okay, it's seen here, 2.17 inches from the bottom. And the moment of inertia, the neutral axis is 62 inches to the fourth power. Determine the maximum value of W if the allowable stress in tension is 6,000 psi. So it wasn't said whether it's a flexure or shear, but it says here that it's tension. So unsa may maka-cause of tension? So it's going to be bending. And if bending ang gisgutan, then it's about flexure. So that's 6,000 psi in tension, and stress in compression is 10,000 psi, and the shear stress is 8,000 psi. So the 6,000 and the 10,000 psi values are the flexural stress in tension and in compression respectively, while the shear stress 8,000 is for the horizontal shearing stress. So basically, we will be drawing the shear and moment diagram. So it's a long process. Although we have an irregular shape of a section, but the problem already gave us the moment of inertia. So of course, to save up time, and you know naman already how to solve the moment of inertia. So I don't have to validate that since you already have kanang napasar na ninyo ang inyong statics. Anyway, this is our illustration. Then what we're gonna do is first solve for the reaction of the figure here. I have already pre-written the letters from left to right. So you have A, B, C, D. And then we will be having a reaction here. I'll be calling this as BV. And this is CV. And by virtue of symmetry with respect to the loading, we would conclude that BV is just equal to CV. No? So BV is just equal to CV, and that's equal to 1/2 of the total loads, which is duha ka W on both ends and usa ka 4W, so that's going to be 6W. And that's 3W for CV and BV. No? Maklaro naman no? Nga even on both sides, left and right. So distributed evenly ang mga forces or ang mga loadings. So BV is just equal to CV. Okay, so after that, if ganan mo validate or if verify kung sakto ni siya, you can do it on yourself. So pwede na mo maka-solve na. And then let's just proceed to the next thing that we're gonna do. Actually mag-draw ta og shear and moment sa ato ang figure. So this is for, I guess this is quite big ra siya. Okay. Alright, so let's drop down a line for A, B, C, and D. So mag-start here. Can we transfer this one? So this is for A. And then this is for B. This is for C. And oops, ito na dalawang B. And this is for D. And of course, let's draw the horizontal shear line. So this is the zero shear line. And do not forget that you have this value here, 3W, and this one, 3W. Right, so starting with, let's draw the shear diagram. So for the shear diagram, let's start from 0. Since there is a concentrated load, at A there would be two values. So first is 0, then the next one is downward ng W. So it's negative W here. I'll just place here the negative W and connect this one. So this is negative W. Please be careful with the units, okay? It will really matter. Okay, remember that our stress is in terms of PSI, or pounds per square inch, and our distances here are in feet. So we have to be careful. So we have the W, and then at point B, we're plotting point B, and there is a concentrated load. So there would be two values, but the first value is the area between A and B. Since wala may area, then let's maintain a horizontal line. And this is still negative W. Then upward, so it's gonna be negative W plus 3W. So it's 2W. So I'll place that here, 2W. Then this is for, yes, 2W. And we're plotting point C now, and point C has a concentrated load, so there would be two values, but the first point is the value between B and C, which is equal to 4W. So let us subtract 2W and 4W. Subtraction because 4W is downward. Okay, so 4W negative and 2W positive, so the answer would be positive. And let's connect the two figures. There. And the value here is negative 2W. And the next value is the difference between the negative 2W and the 3W. So the answer would be 1 here. So I connect, and this is W. Okay, plotting point D. So there is a concentrated load at point D. So there will be two values at point D shear, but the first value is between the C and D. So there is no area. So same gihapon. It's going to be in this figure, W. And to close that one, it should be 0 here. It's 0 because this is downward W. So that's minus W, and a positive W. So that's 0. And do not forget that you have a 0-degree line here. You have a first-degree line. Also, do not forget that there is a point of inflection. Point of inflection that we have to drop down a line. Somehow, the location of the point of inflection is at the middle because the distribution of the loads are perfectly even on both sides, left and right. So it is at the middle. So 6 feet man, so at the middle it's 3. But if you don't know how did I get this, it's actually from ratio and proportion. 2W over X equal to 2W over because this is X and this is 6 minus X, something like that. So 6 minus X, therefore you can get X equal to 3, and 6 minus X, of course, it's 3. Okay, so we're through with the shear diagram. Let's continue with the moment diagram. In plotting the moment diagram, so we need the area of the shear, but first let's draw the horizontal moment line. Okay, so in drawing the horizontal the moment diagram, so ato i-evaluate at point A, B, C, and D. There is no moment diagram, moment load, therefore we will not be having two values of moment at each point. Kausa lang moagi. If that's the case, then let's proceed. Starting with point A equal to 0. No? And then, the next one is the area. So, pila man na tong area, ani? So, the area here is... What is the area? It's the product of the distance, 2 feet. So, 2 feet na siya. So, it's going to be negative W times 2 feet. That's the area. So, therefore, it's negative man. So, it's down. Nasa ubos. Here. And the value here is negative 2W feet. Do not forget that. And connecting a line, this is at 0 degree line. No? So, this is at first degree. No. And this is at first degree. Okay. Next. We will be adding this area. Since magplot naman ta diri nga portion, so manginahang lang ta sa kaninga area. Let's solve for that area here. I just coloran lang sana ako because it's really satisfying. Sorry. We have this area. And actually the area is computed as the triangle. 1/2. Base nga 3 feet. And times 2W. So therefore the area is makancel out ang 1/2 and 2. So it's 3W feet. Okay. So if that is 3W feet, then we're gonna add this one. We're gonna add this and this. So negative 2W feet and positive 3W feet, it's positive 1W. So here, this is the 1W feet. Okay, how do we connect this? Of course, do not forget, this is positive decreasing, this is negative decreasing, this is negative increasing, this is positive increasing. So if we try to draw a line from left to right, ang nahitabo sa line kay ni gamay. So it's decreasing, and then the area is found above the 0 shear, so it is positive decreasing. What is positive decreasing? That. Okay, now na nato siya pag-connect. Say it. So this is positive decreasing at second degree. No? Okay, first degree man na siya. And next, we need another area para ma-plot na sad nato dira. Okay, the area is here. Kani siya nga area. So we need this area. Actually, the area is just the same sa kani, no? So ato lang i-rewrite. It's actually negative 1/2 of here. Negative 1/2 of negative 2W times 3 feet. Therefore, the answer here is negative 3W feet. Okay, so we will be subtracting this negative 3W feet and positive 1W feet, and the answer is negative 2. So here, I'll just place here the negative 2W feet. And of course, we will be connecting. That is, if you try to observe this, it is increasing. The lines are increasing. Then the area is found below, so it's negative. So negative increasing. Where's negative increasing? This one. So this is negative increasing. And this is at second degree. Right. And for the last one, we need this area. This area here is the product between the height and the base. So the base is 2 feet and the height is W. So it's 2W feet. And what we're gonna do is subtract this 2W feet and then this negative 2W here. So it's basically 0. And then, well, how do we connect that? From 0 degree, may mo siyang first degree line. So it's a straight line. And this is at first degree. So this is our moment diagram, shear and moment diagram.